Okay, thank you very much. Good evening, all. Um, Today I'm going to um, okay. Today I'm going to discuss about the importance of fire modeling for safety evacuation. Uh, this will be my content. First, I'm going to do some introduction about fire hazard because today evacuation based on building uh, fire due to fire building evacuation due to fire. So today I'm going to discuss about a little bit of fire, and then I will move to evacuation modeling and the conclusion. So as we know, the fire is a very important source of energy. So most of the time, day-to-day life, we use fire. So that's very important source of energy, but within controllable limits. But when it's come to uncontrollable limits, we are considering only buildings, especially tall buildings. When we consider about uncontrollable level of fire, it will become a disastrous hazards. So fire will not be a unique thing. So it will change time to time and place to place. So it can happen at any time, at any location. So this will be this is a daytime fire, and you can see is at night time. So when it's become uncontrollable limit, the fire will be can be rapidly spread. I can give you example, the Greenfield Tower fire, and it's very hard to control and extinguish. So let's discuss about some fire statistics. This is about fires in structures under construction. We saw the fires in constructed buildings. This is the fire statistics for structures under construction. You can see the keep increasing pattern of fires in under construction, and you can see the various type of cases, and by time of day the percentage of fire occurring percentage. So mainly this kind of fire, because of the changed geometry and volumes due to architectural purposes and the construction materials. So because of this conversion of construction materials, the nowadays modern construction material, the construction materials and the furnitures can have a high fuel load, and this will be a synthetic materials, so they can ignite very fastly and release high peak heat release rates. And this is the firefighters deaths due to fires. You can see the several reasons. The smoke, due to smoke, becomes the highest reason for these deaths, not the burns and not the crushing injuries. So because of that, we need to ensure fire safety inside buildings. So main aims of the fire safety can be, the first one, we need to save the lives, and then the property losses, and we can add environmental losses also. We have a mainly two type of fire protection: active fire protection and passive fire protection. So you all know the active fire protections. So they are actively participate to fire, sometime give a notice, and sometime to extinguish the fire. So these are some fire protection, active fire protection you can find inside the buildings: manual call buttons, smoke sensors, blinkers, hose reels, etc. And the passive fire protection. As civil engineers, we are responsible for these kind of passive fire protection. So we have to limit the fire, and we have to design elements against fire. So sometimes we have to provide protective coatings. We have to compartment to limit the fire spread. Likewise, considering all these fire protection method, you can see here again fire statistics based on sprinkler operation and effectiveness. You can see the sprinklers fail to operate 8%. So there will be a chance of failed operations. So that can lead to severe hazardous situations. So what we can do first, if you find a fire within a growth period, you can try to extinguish. Before that, so we have to ensure that we will try to prevent fire before it's ignite. So then we can try to extinguish fire within growth period. So all active fire protections also effective within this growth period, fire growth period, before flashover. Then if we can't extinguish fire, then we will try to control the spread. Then that also not possible the cases, we have to evacuate. However, it's better to evacuate when you realize there will be a fire. So let's move to evacuation. So during firefighter process, firefighter actions, this building collapse. So we have to evacuate as soon as possible when there is a fire. We don't know whether this building remains stable before we evacuate. Sometimes we have to evacuate like this if you don't have proper evacuation methods, proper evacuation strategies. This is also an example. This will be an evacuation method. If you don't have any proper evacuation plans, guidance from buildings. So you can realize the importance of design against fire as well as the evacuation. This is a diagram, shows the fire progression with damage severity. You can identify that the smoke detectors, when the smoke detectors activated, you can see there will be a small smoke. And when fire extinguishers, fire suppression system sprinklers activates, there will be a dense smoke. So these kind of situations you can experience like this. This is a case inside Greenfield Tower fire. Inside Greenfield Tower fire, Imagine you are inside the building, and how you feel when you find this kind of situation. You can't find any evacuation paths. You can't find, even you can't make a step like this situation. So we need proper evacuation before fire propagate that kind of situation. So during a fire, most of the time when we enter the buildings, we go through lifts without staircases. But during a fire, when fire alarms activated, we have to evacuate immediately, but you will not allow to use passenger lifts. So you have to find shortest path, but it should be a safe path. So in high-rise buildings, evacuation govern these things: heights, geometry, number of exit routes. I will discuss in next few slides these points, and the structural performance as I discussed before. So within all the people inside the building have to evacuate before it fails. So we have to ensure that structure remain itself the final person who evacuate from the buildings. Typically, in tall buildings, you can find these kind of emergency exit plans. You can see the left side picture, emergency exit plan. This is a very simple geometry of the building, very simple geometry. Then you are that location, then this picture guide you towards the evacuation paths. Here you can see, in case of fire, do not use lifts, use stairs. Think you are inside this building at a location during a fire. Can you find any staircase during a panic situation? Can you find without any guidance? Most of the time when you go to a building, that will be a new building. So you will not be familiar with these arrangements. During a fire situation, sudden fire, you will be a panic. So when you are panic, you can't find any path. This is a complex geometry. So then this will be a good method to develop proper evacuation plan. This kind of geometry, we can model this geometry and put some people inside the building, and we can study about the shortest evacuation paths. Then we can develop a proper evacuation strategy. So this kind of modeling can be used to optimize evacuation strategy, calculate more accurate evacuation times. Then we can evaluate the capacity of doors. Then based on that, we can change the doors or increase the sizes. Then we can identify evacuation paths, possible evacuation paths. Then we can incorporate the fire model into the evacuation model. Then we can study about smoke propagation with the evacuation. So we can study both, and they will provide these advantages. So in this kind of modeling, we can include the walking speeds, then the possible paths. Then we can include waiting times, exit location, available paths, like that. These data we can include into these kind of evacuation modeling. So this is an example. We selected our office flow for this study. Then we develop the model. This is the model, and we simulate considering active fire protection and passive fire protection features. So we include all these smoke detectors and sprinklers and these kind of data. So we can find, referring to the literature, when fire alarms activated, the recognition times, response times, travel speeds of the people. We can include the several different speeds for people, walking speeds, and we can calculate the evacuation time based on that. So you can see this is a model we developed considering without any fire protection, without any active and passive fire protection. You can see the smoke spread before the evacuation. So then we can identify based on the fire models the time to activate smoke sensors and sprinklers. Then these data we can include the evacuation model, then reanalyze the evacuation time like this. So when there is a fire, this is with active and passive fire protection. The smoke limited to first floor only, and the activate of sprinklers and smoke sensors data we included. Then it will result the reduced evacuation time. This is an example. This is another example we did for a different geometry of the building. You can see here we try to identify the capacity of this door. You can see the capacity. So this will matter for final evacuation time. Likewise, we can include all these data, calculate the proper evacuation, the accurate evacuation time. So here we will combine fire model and the evacuation model. You can see how the people evacuate. So these are the example of evacuation models. The people follow the shortest exit route. Based on these, the moving patterns and moving direction, we can develop proper the evacuation paths and the strategies. This is another example. CSEC did the evacuation model for Lotus Tower and calculated. So this evacuation time will govern the required fire protections for the structures, and this kind of model we can use to do a performance-based designs. Based on the performance, we can decide the required fire safety. Here, we can define the exit, main exit from the building. Then all the people follow the routes towards this main exit. So then we can perform a drill, evacuation drill, to calibrate the evacuation model results. And this is a Lotus Tower evacuation exercise we did, and calibrated all the results from the model. Finally, we can develop this kind of emergency exit plans based on the results from the model. These paths we can identify and we can develop, created based on the results from the model. And what you have to do is, when there is a fire alarms activated, you have to follow these green lights. This will guide the path as given in the escape plan. This will guide the path towards the main exit. Finally, you have to go to the assembly point. Then the people head count will calculate by the fire department or whatever the resource that personals. Then it will help to check whether there are any people inside the building. So finally, keep in mind, based on the latest experiments and models, you have less than 15 minutes to evacuate from the room of fire origin, and you have to follow the evacuation path. As civil engineers, we design the evacuation paths for several fire ratings, for 30 minutes, 60 minutes, 120 minutes, based on the prescriptive base. But based on the performance based designs using models, these kind of models, we can actually identify what is the fire rating required, and we can provide the required fire ratings and use that kind of material. Then that will decrease the unnecessary cost that will need to provide the fire safety. That will be the end of the presentation. Thank you very much for your kind attention.